So we are starting with the rotorcraft operations and aerodynamics. This plays a lot of weightage with respect to your this thing, what we call with respect to your certification.
Okay.
Let me know once you are able to see the screen.
Yes, and now it is visible.
Rotorcraft operations and aerodynamics. As we have seen the flight fixed wing operations and aerodynamics, which is similar to your what we call your aeroplane. Okay? Whereas the drones, what we actually call, okay, it is basically we see drone with respect to the rotorcraft. I mean, nobody calls aeroplanes or aircraft as a drones, but when we see four propellers, four or six more propellers, then we normally see them as a drone. Okay? And that's how we mentioned that this is actually the drone and all. So let's see now what are the things covered into it. So what is the basic drone overview? Types of multi-rotor drones. Then we will, in detail, we'll talk about the quadcopter anatomy and terminology to it, and then we'll see what are the inner electronics of a drone, and then the applications. I mean, we touch base with a lot of applications related to quadcopter as well as the use cases of the quadcopter or the drones, what we call. So, what is actually a drone? Drone is nothing but a aerial, ground or underwater vehicle without a human pilot on board. Okay. So that is what is actually the definition of the drone. It is also called as unmanned air vehicle. Okay, AV, UAV. Okay, unmanned air vehicle, or also it is called as remotely piloted vehicle. Okay, RPV, or also it is called as RPAS, remotely piloted aircraft system, or also called as unmanned aircraft system. Okay. So when S is attached, okay, you see S means what? System. Okay. So a lot of people make confusion here. How is UAV different from UAS? Or how RPV is different from RPAS? Okay. Or RPA also. Sometimes even it is written as remotely piloted aircraft. Okay. But when S is, okay, when there is a S, okay, here instead of vehicle it is system. Instead of here vehicle it is system. So when S is attached, system means what? On its own it is not going to have any function, right? It needs a remote control. It needs a ground station, all that thing. So when you have these kind of things along with it, we call that entire system. The entire system is known as unmanned aircraft system or remotely piloted aircraft system. When you see that thing. RPAS is nothing but your remotely piloted aircraft with GCC, ground control station or remote control. Then it is called the complete system. It's called RPAS. Okay.
Okay.
Now, how does actually the drone fly? Drone can be flown two ways. We have seen how drone can be flown. One is using a remote control. So the human operating the drone by using remote control, or fly autonomously with the help of onboard computer. That means you will have a ground control station attached to it, and then your drone is controlled, or it is given a commands to the ground control station. Either maybe a mission is and then using the flight controller on board, it will fly on its own and perform the actions as required. So there are multiple types of drones, different types of drones, depending upon the number of rotors. So even you have two rotors called bicopter, or two rotors. When you have three rotors, then you call it bicopter. When you have four, you call it as a quadcopter. When you have six, you call that as a hexacopter. When you have eight blades, you call it as a octocopter. However, out of this all, tri, quad, hexa, or octa, quadcopter are the most popular and widely used. So, quadcopter and hexacopter, I would say, are the two variants which are very much widely used. Hexacopter is used where you need more thrust and you need more stability. The fixed blades need more stability, and it can have a capacity to rise the weight or pick up the weight of a very heavy weight, like your fertilizer tanks or payloads. In that scenario, you will use hexacopter or even octocopter in that scenario. The more propellers you put, the more capacity to lift what you have. But for a normal drone operations, quadcopter is more enough because it will have more rotating and it will lift easily, and it is very very stable in quadcopter is very, whereas it is very bicopter or tricopters are very difficult. You need to write a very complex algorithm to manage quadcopter or tricopter. What are the pros of the pros and cons? We have seen this also uh, comparison. So most pros are vertical takeoff and landing and the hovering capability of the multi-rotor drone. Then operations in a confined space. This is another important uh, importance or pros of the multi-rotor drone. Operations from a confined space. So in a small space, it can take off and perform the actions in a smaller. As you said today morning, that when you want to do surveillance in the tank, those are very confined space environment, okay? Very small side space, what we call. So in that scenario, your multi-rotor will be very much helpful. Okay. Whereas, what are the cons or what are the limitations? So limited endurance compared to the fixed wing, less chance of a recovery in case of multi, in case of motor failure. Okay, like in fixed wing, what happens if there is a failure on thing, it can still glide. Okay, it can glide, and there are options for recovery for a fixed wing as well as multi rotor. Like there are some drones which are designed with the what we called parachutes. Okay, but they are still not so successful because a lot of time people have seen parachutes get entangled in the propellers or some other challenges. So there is one or two drones which have been designed with the parachute for a recovery in case of motor failure or any kind of failure. It could be a battery failure also. When there is a battery failure, entire drone stops working. So there is a complete loss of power. In that scenario also, it is a failure. So in that scenario, you can always have a mini parachute which can at least minimize its actual crash. Okay, so at least it will come down slowly on the ground, or you can have some mechanism for it to be captured safely. Okay, rather the drone coming from 400 feet straight to the ground, you can have it safely. Minimal damage could happen to the drone. Whereas again the speed is limited compared to the fixed wing. So limited speed is there. That is why it said cannot perform the high altitude, long endurance operation. That is the limitations of the multi-rotor drone. The multi-rotor drones you can use it, though you can have a vertical takeoff and landing. It has hovering capability. Also, you can perform operations in a confined space. But because of the design and using electric motor, you have a limit. Again, that those are four motors. It has to give power to the four motors. You have a limited endurance, then chances of recovery is very less compared to in case of motor failure or any other failure kind of thing. Limited speed, and since these all limitations are there, it cannot perform the high altitude, long endurance of along. Okay. So now, single rotor drones, what we call them as helicopters. So they, since these are IC engines provide, the lift produced by single motor rotor is very high efficiency. high endurance since it is using a gas powered engine or gasoline or whatever fuel it is using, not the normal electric fuel or anything. So that's why you have a higher endurance. So earlier, you would have seen the helicopters were predominantly used before the drones, I would say, scale surveys and agriculture. But the downside of using the helicopters are the complexity, connectivity, cost, vibration, and also danger of large spinning wheels. So you can't come closer, very close to the ground in a complex situation or complex terrain kind of thing. This can be used for surveys, big surveys, or big agricultural projects where you have a huge farmland and you need to do crop spraying kind of activity, crop spraying. In that scenario, earlier helicopters were used, but due to complexity and operability and the cost involved into this, these are not very favored drones by the people. Single rotor drones, similar to the helicopters, are not very famous to use or very flexible to use. Whereas if you see, you have something called hybrid VTOL. These are nothing but a combination of fixed wing and multi-rotor. You can take off and transition from multi-rotor to fixed wing. Operations can be done in a fixed wing, and then again landing can be done in a multi-rotor. Now, advantage of this hybrid VTOL is long range, higher endurance, hovering capability also is there in operation from a confined space. Again, though it has a wings, but still it can perform a smaller area depending upon the way you have designed your activity within that space. So you can transition from wing to multi-rotor and from multi-rotor to as on when required. So that's how you have a long range, higher endurance, as well as hovering into the hybrid vehicle. Let's see some history part of the drone. So if you see the history of the unmanned aerial vehicle, started in somewhere around 1849. Okay, so Austrians basically made some balloons measuring 5.7 meters in diameter, and they attacked the Italian city of Venice with unmanned balloons loaded with explosives. These were balloons, and they will fit these balloons with the payloads of explosives. So as it takes off and moves in the air, you will see over the period of time, as it goes in the air and certain distance, automatically the explosives are getting detached from the balloons and they are falling on the ground and that explosions are going. So you can fly those balloons from one location and it will reach some village or some city in Italy, okay, and it will fall. Those explosives will create damages. So that's how this unmanned balloon were the first uh, usage, what people called of unmanned aerial. So these were not flown or driven by any person or this unmanned. It was. That's why it is called UAV. Again, this application or this aircraft was used by Japan also in World War II, from where they have flown the balloons and they have also similarly fitted the explosives. You can see this documentary on YouTube where they have fitted these explosives and they have put the timer and all. So based on their observation and testing, they know like okay, if I flow the balloon from here because of the Pacific uh, winds, okay, they will reach the western coast of America after certain time, and then they have calculated and then they thought that after that it is on the land of the western coast of America, it will slowly start dropping these bombs, and it will start creating havoc under the civilian cities and all of it. But I would say, fortunately or unfortunately, These balloons, which were loaded with the aircraft, they didn't land up anywhere into the civilian area or something like that. I think only one balloon was succeeded in this kind of operations, whereas rest of the balloons either they were flown or those they got missed time, not reaching the land or the terrain locations. Most of them are lost within the sea itself, because you see Pacific Ocean is a very big ocean, and it is not only with respect to the width but also from north to south. It covers a big area, so it's very difficult to have such kind of device unmanned or uncontrolled to reach its specific target or anything. So that was the usage of the unmanned aerial vehicle in two scenarios earlier. So if you see the evolution, like as we talked about, Austrian used bomb filled with balloons against the Venice. Then Nikola Tesla also demonstrated a boat in a pond in New York to be operated by the radio waves. So that was in 1860. And then subsequently, balloons again were used for surveillance. Okay, and then U.S. used balloon-filled balloon. Sorry, U.S. used bomb-filled balloons during Spanish-American War in 1910. Okay, uh, but as the aircraft or the aviation field evolved, there were aircraft which were made which can be remotely controlled, and they were made to do like kind of missile or suicide bomber kind of thing. Okay, so those aircraft were flown remotely, and they were targeted to a particular location to hit the enemy facilities or something like that. So 1940, this is during the start of the World War II kind of thing. Whereas after the war, most of the things were used. Again, most of the drones initially were used with respect to the surveillance, reconnaissance missions, or the defense related attacks during the wartime. But in 1974, the guy from Iraq, okay, who actually migrated to Israel and then later on migrated to America. Okay, he took the American citizenship. His name is Abraham Karim. Okay, he is supposed to be the father of the modern drone. He made the first drone, and which was called as Albatross, or whatever the current drone we see. Okay, the Predator drone is made by his company. Okay. So Israel and the American military started using this type of drones in 1986. Then during the Gulf War, also we have seen the usage of drones. At least one UA was airborne at all times in first Gulf War. Okay, that is was 1991. Then later on, when in the normal conditions, drones were mostly used for climate and environmental usage of the drones. You can see Predator used for surveillance and use of Hellfire ASM missiles in combat in places like Kosovo, Afghanistan, and other war zones. So Predator drone was more stable, and it is widely used by American defense and been used mostly in the desert or in the war-like situation. Then you have a Reaper kind of drone, more advanced version of Predator used in combat mission in Iraq and Afghanistan. And then we saw, so if you see from 2007 onwards, or I would say right from 2001, okay, since 2001, actually the quadcopter drones came into the picture very much, and initially they were used mostly for the what we call the aerial photography and videography. And that's how actually the drones came into the civilian environment or civilian scenarios or commercialization scenarios. And initially it starts as a general toy for camera shots and all the things. And uh, US at 2014 started taking seriously, and that's how you have seen that ARPA's committee was formed by ICAO in 2015, and that's how even during that time, even a lot of other companies across the globe like DJI or Parrot Systems or Autel Systems all those a lot of companies which makes smaller versions or the commercial versions of the drones started during that sense, and then we have a lot of states, or I would say countries, adopting the ICAO standards for our pass. Okay, so really the drone market started from 2010 2014. Okay, these 5 years normally it was at a very developing countries or developed countries, I would say, where people have started utilizing the drones and slowly passing. So, but the consumer drone popularly at all time drones got initially bad name due to close calls with the commercial aircraft. Issues such as no-fly zones and risk to commercial aircraft create a divider between the people who like the drones or hate the drones. Okay, so by 2016, as I said, US has adopted the framework for flying the drones. So by from 2016 to 2018, there was a huge adoption in the drones, and US has a very big market compared to our market as of now. They have used drones for every segment of their life. Okay, be it infrastructure monitoring, agriculture, or surveillance, or even disaster, or even right now you must have seen Amazon Prime, or a lot of organizations are using drones for delivery of the parcels and all that things. So by 2016, 2017, you see the lot of huge adoption of the drones in different locations, be it US, be it Canada, be it Australia, or be it in Europe also. However, our side, we were still evolving at that point in time. So 2000, as we see, US market was gearing up and started adopting the drones in a big way. We had got our first car. Okay, so we call it as a car. So that was the first car which was released, and with lot many. I mean, there were lot many issues and lot many open statements were there into that, where lot many challenges were there in understanding the rules. The way rules I have explained for 2021, the car whatever we had was not that simple. Okay, a lot of complexity and lot of ambiguity, clarity was not there in that. So a lot of people were not able to understand those documents and all that. So later on, Indian government thought that we need to, if we need to be forefront into the drone segment, we need to have a very simplified rules and simpler operations activity with respect to the rules. And that's how by 2021, 25th August 2021, we have the drone rules predominantly from the rotorcraft operations initially. So, though it covers your rotorcraft, aeroplane, and the hybrid, but focus was more on the rotorcraft. That's why you see the rotorcraft has evolved more. And when we talk about drones, it is more people see is the quadcopter or the rotorcraft drones, not the aircraft type of drones or hybrid type of drones. Okay, those are not meant specifically for the civilian or the for the end user kind of activities. Okay, so as we talk, father of the drones, Dr. Abraham Karim, born in Baghdad, okay, later moved to Israel in 1951. He was actually aeronautical engineer from the Tekon Israel Institute of Technology. Built his first drone during Yom Kippur War for Israeli Air Force. In 1970, he immigrated to United States, founding a leading system incorporation, and started manufacturing his first enterprise drone, that is Albatross, okay, which is later on adopted by the US Army, so inventor of modern day combat drone, which is known as Predator, which brought him name the title of father of the drone, okay, because these were the first commercial or the real drone which came into the picture and adopted in a big way, and still date this, I mean, people are still using these drones, Predator drones. Okay. That's why he got the title called father of the drones. Okay, so what are the future of the drones? Future of drones such as factors such as cutting edge design, engineering, and still technology advancements are key to with a different differentiator for the drones in the future. So you can see a drone taxi or a drone bike, what we would call. Okay, it could be one or two people flying these drones, but these are very initial stage. We still do not know. I mean, these are very complex design and lot of challenges are there when we see these kind of drones flying across the location from one point A to point B kind of. Okay, whereas there are drones which are also getting developed with respect to the agriculture environment, autonomous flying, autonomous breeding or spraying activities. There is a concept of a drone where you talk about lot of time when you fly the drone, we always see the propeller is the major challenge. What you see, you can get entangled or some problem could happen in the propeller. So there is something called propellerless or bladeless drones. Okay, so these are something like no propeller, no moving part inside these drones, which could have a challenge when they are flying. Okay, so these are still in a initial stage of development and testing and other things. Then again, these drones are used for supply chain and other things. And then we see a lot of drones are being made in a miniaturized version, basically for flying and all that kind of thing. So some drones are made like a small omnithopper or bird-like or insect-like kind of drones, which these are mostly used for getting the footages or spying or monitoring kind of activities into these. Okay, then there is Tesla also has come up with a drone concept where it introduced two different types of propeller, upper and lower propeller layout, carrying the payload in middle. You can see here, up and down. Okay. So upper and lower helps in the takeoff and landing, between which the drone shifts into the regular side by side propeller orientation. So it depends on how the propeller is there, and so basically up and down it can be used for vertical motions, whereas when it is in a horizontal combination, it is basically for flying or moving forward direction kind of. So here you are actually using only two propellers rather than four propellers. That's how this design they are trying to evolve so that it can be used in future. But still, these are at a very initial stage. There are a lot of challenges and complexity is required to be overcome with respect to the stabilization of it. Okay, so these are up till now. These are only about you know what we see, what we envisioned or what we see could be the possibility into the drones. Okay. Now let's see what is the quadcopter anatomy, okay, or what are the components into the quadcopter. So you can see there are in a quadcopter you will see first something is called propellers, or props, what we call. Okay, looking at the props. Then propellers, below the propeller you will see the motors, which is actually a BLDC motors. Now to give the power or a control power to these motors, we need a circuit which is called as electronic speed controller or ESCs. Okay. So propellers, motors and ESC makes the one component or a propulsion system for the drones. Okay. So like this quadcopter you will have four motors, four propellers and four ESCs fitted to it. Okay. Then to control the ESC or electronic speed controller, you need something called train, okay, which will give a right amount of signal to the ESCs, and where ESC will give the based on the signal it will give the voltage to the motors. Okay, so with that you need a flight controller. So it could be a different flight controllers are available. Okay, as you fly this quadcopter drone, you need to know where it is flying. Either you can visually see this drone flying, but at a very high speed, it becomes very difficult to know the orientation of the drone or where it is flying. Or if I'm flying in a very confined space, it becomes very difficult from far off flying it. Okay, so I'll always put something called as a first camera video camera, first person video camera. Okay, so FPV, what we call. So we'll have a FPV also. Now, if I want to capture the footage, okay, this is only for viewing or maneuvering perspective. The camera is there. A small, low speed camera we will putting it. But then, if you want to capture more detailed footage of the area or the location, or we are doing some kind of project or activity, and we want to have those inputs, we may fit a large resolution camera or a camera which could have a possibility to capture the data on its own, okay, on its memory card or storage and all that. Okay. Here only the FPV is only transmitting real time data to the person who is actually using the FPV goggles or the thing. Whereas this camera will actually capture the data as it is the load. You will have a receiver. Okay, this receiver is basically communicating with the drone and the remote. Okay, so you will have a receiver signal. As my remote control is transmitting the signals to the drone. Okay. Then below the drone frame, you will see a battery pack, which is a powerhouse, or which is actually powering the drones and its different components, like the power for the flight controller, power for FPV, power for the motors, power for the gimbal with the camera. All that things will be powered through this battery only. Okay. So there will be a small electronic board would be there, what is called as a power distribution board, and then that will be connected to different devices on the drones. Okay, so this is a quadcopter with open end structure. Okay, so you can see all the components on the drones. Whereas the drone what we fly, like DJI drones or even the type certified drones, they will be more or less will be always having what we called connectors. Okay? They will be always have a canopy, not connector, canopy, covered structure between. So you will not able to see all these things. Okay, you can see motor, propeller, but you can't see ACs. Especially the electronic components, you will not able to see, or the electronics part, or the avionics parts of it. You can only see a connector coming out of it, and you can just connect the battery below, and you fix the battery connector with the connector what it has. Okay, even the gimbal and everything would be fitted, and then most of the wires would be going inside the cover or the canopy of the drone. Okay, so you have any questions on the overall anatomy of the quadcopter?
No, sir.
No, sir.
So now quadcopter. Now again we talk about propellers. So propellers is nothing but converts the rotational motion to the thrust. So as propeller move, uh, they move. As they move at a very high speed, that high speed motion or rotational motion will convert your into the thrust. So all the four propellers moving will create a huge thrust, and it will lift the drone in the air. So if you see the propellers, there are two types of propeller. One is the pusher propellers, and other is puller propellers. Okay, so based on the fitment of the propellers, they are called as a pusher or puller. So pusher are basically, your statement is written pusher is clockwise and puller is counterclockwise. But again, depending upon the propellers, you will able to define different types of propellers. Actually, if you see the propeller here, the images on the screen, the propeller dynamics can be modeled by the Bernoulli principle and the Newton's third law. Okay, so I was telling you about it. So if you see this propeller, do you find any difference, or do you see the application of Bernoulli principle into the propeller?
Uh,
Yes, they have the curvature.
Yes. So you can see the curvature similar to the wing. So if there is a curvature, if you see this part, this is your leading edge.
Leading edge.
Wherever there is a sharpness or the curvature going down, that is your trailing edge. Okay, so at is it cutting the air? Okay, so it is using the Bernoulli principle, but as it moves or it converts the rotational motion at very high speed, it is pushing the air down. Okay, and it is generating the thrust. Okay, which results into the lift of the drone. Okay, now if you see these two propellers, do you see there is a difference in these two propellers? Any difference do you see in the propeller,
The,
or
di-
they are
the,
same?
the difference in the propeller direction.
Correct. So if you see, they are actually the propeller made in opposite directions.
Yes.
Okay, if you see here, you have a leading edge, and this is the trailing edge. Whereas if you see here, this is the leading edge and this is the trailing edge. So they are two different types of propeller. So if you see this propeller, okay, the black propeller, the black dot propeller, okay, this propeller is called as clockwise propeller. Okay, it will flow, it will move like this, clockwise. Okay. Whereas if you see this white propeller, a white dot propeller, this propeller is called as anti-clockwise or CCW, counterclockwise propeller. So this will move in this direction. Okay, so anti-clockwise. This is clockwise. I will come to know. I will tell you about what is the, why these two types of propellers are being used, okay, or what is the consequence of, or why do we have this type of propeller. Okay. So we'll just park that topic over here. Motors are used to rotate the rod. Now you have to give a motion to this propeller, so you have to use motors. So mostly in quadcopter we uses brushless DC motors because of their high efficiency and long lasting. The key parameter to focus is motor speed, thrust value, compatibility, AC and compatibility. So when you are using a motor, actually these are open motors. Okay, here if you see the armature, you can see the armature. If you see the DC motor, you will not see the armature into it. Okay, but whereas in BLDC motor, you can see the armature over here, and it is clearly visible. Only thing is that these are brushless, so there is no brush connecting to the armature over here, because here your armature is fixed. What is actually moving is the magnet which is moving. In the DC motor, your armature is actually moving. That's why it needs a constant power. The brushes are being connected to the armature so that it keeps touching the armature and providing the voltages, and that's how the armature used to get voltage. But here your armature is fixed. Okay, so actually your armature is not moving. Okay, so that's why it is not heating up very high. What is moving actually? The magnet around the armature is actually moving. So as you induce the current into the coils, because of the difference in the magnetic field, it pushes the magnet further. Okay, based on the direction what it is being made. So now north becomes south, south becomes north, north becomes south. So all these differences makes the magnet to move in a forward direction. Okay, difference into the coil. Okay, so that will make this motor to move. So the more faster you change the voltages or between the coils, it will keep on moving faster. So it will push the drone, the magnet further and further and further. So it keep on moving. So that's what it generates the rotational motion, and as it gets the enough rotational motion, it can generate the thrust. Okay.
Yes.
Okay. Now, as you see, propeller and motor is a unit, but then you need to give a proper speed, okay, or proper voltage to the motor. Okay. Now, how that precision speed, whatever RPM I need that motor to be rotating, is being managed by the ESC. Okay. So it is ESC or the electronic speed controller is used to vary the motor speed with precision. Okay, this can control the direction of the rotation of the motor either in CW or CCW. It can also act as a dynamic brake. That means even ESC can stop motor from spinning, okay, immediately. So it can have that dynamic braking system also. Yeah, so that is what when we do disarming the drones or disarming the motors. Okay, and then also, since my battery will be having a raw power, raw voltage, so this is also has a eliminating circuit for powering the flight controllers and receivers. Okay, so a lot of time the flight controllers or receivers, this signal what it gets, it will have a very controlled power with it. So you can see here there are only two wires which are connected to the battery, but this has a very uh, intelligent circuitry made in such a way that it protects my motor, it protects my electronics and all that things. So the AC is a very important circuitry part of the drone, which not only gives the uh, or very used to vary the motor speed with precision, but also eliminating the circuit from powering the flight controllers and receivers. Okay. So it will actually controlled very controlled power it will give it to the flight controllers or receivers. Now let's see what are the flight controllers available. Okay, so which is we also called as the brain of the unmanned aircraft system. It helps in the flight stabilization, navigation, and fail-safe redundancy. Most common flight controllers developed are Ardu Pilot, either DJI. We have DJI N3 NASA or M-Lite NASA MV2 E3 etc. or could be customized. So a lot of people have taken this is again a standard uh, flight controller through Ardu Pilot called Pixoc. Okay. So there are more versions of Pixoc available, more stable and more complex version of Pixocs are there. Like Pixoc Cube will be there, Pixoc Orange would be there, Pixoc White would be there. Okay. So this is very basic version of Pixoc available where it can use to control the drone and have your flight stabilization, navigation, and fail-safe redundancy built using this flight controller for your drone. Okay. Then there are, as I said, there are different other flight controllers are also available, like DJI is there, or even there are separate flight controllers from Ardu Pilot also is there. Okay, in 3 NASA and all that stuff. And then there are again some custom built flight controllers are also there. Very small, complex kind of flight controller. But widely used is the Ardu Pilot Pixel. Okay? Orange or white, orange cube or white cube kind, what we call it. Okay. Now, if you see the airframe is the most important part, which actually binds everything: your motor, propeller, ESC, your flight controller, landing gear, all that things is attached to the airframe. So UA airframe consists of housing enclosing the electronics, motors, boom bars, and the platform. There are different configuration of the quadcopter. It could be in H shape, it could be X shape, it could be plus shape, or it could be in H hybrid also. Okay? Again, depending upon hybrid. Hybrid means here it is not exactly looking like H, but like little bit X and H combination kind of. Okay. But you can see here it is completely like I shape or H shape, and this is again X shape. Okay, or you can see here plus shape also. So different about it, but overall, see this is just the design of the frame. It really doesn't matter because if you see from the orientation of positioning perspective, the motors are at the same position where they are supposed to be. Okay, so four motors in four corners would be there. Only thing is how they are connected to each other physically. That is how the frame is been designed. Okay. So widely used frame is mostly the X shape for the small quadcopters. For a bigger quadcopter, some are been designed either in a H or even in the plus shape also. Addition shape. Okay. So again, depends upon depend organization to organization or OEM to OEM how they want their drone to be designed. How they they design their drone for for the certification purpose or flying purposes. Like if you see what we call as Inspire, DJI Inspire is somewhere like a S-shaped drone, whereas there are other drones which are in X-shaped drones. Now, if you see to power the drone, you need a power pack, okay, or a battery pack, what we call. So it is called as power plant of the UAV. Okay, so the power plant of UAV is nothing but it is a rechargeable LiPo or lithium oil batteries. These are widely used batteries because of high energy density compared to the conventional battery. Okay, that's why we use LiPo or lithium ion batteries. They vary by discharge rate, capacity, and voltage. So if you see the discharge rate, okay, what is the discharge rate? How many cells does it have? How many voltage? Like this is two cell, 7.4 volt, and 5000 mAh. Okay, and discharge C rating is 50 cycles, okay, of capacity of the ampere rating. Okay. So here you will have two cells only, but which will giving you 7.4 voltage, okay, at a time, and it will only give you a power of 5000 mAh. So more the power, Okay, more the power, more the voltage you will have, the more cells you will have. So if you see six cell battery, okay, so this will somewhere around 20, 21 volt or more than that also. Okay. Whereas even the capacity could be somewhere around 16,000 mAh or 22,000 or even 21,000, 22,000 or 30,000 mAh, depending on. So higher the cells, the more capacity it will have, the more voltage it will have in the battery. So this will be more clear when on the third day when we go for a battery charging activity, and then we'll see the actual batteries which are being used into the drones. Okay.
Yes, sir.
So as you see, the quadcopter, it is not just the drones which will be flying, but we will be flying the drones for particular use. Especially there would be a payload where we'll be having a camera with the gimbal. Without the gimbal, also we can attach the camera to the drone, but then it has a limitations over there, because if you want to take the picture in angle, I have to tilt my drone, okay, which will actually put a pressure on the computational part of the drone. So if I want to avoid, I can always keep my drone in a hovering mode, and I can control the angle of a drone using the gimbal. So I can do pan and tilt control motion. Okay? Pan and tilt motions I can do using the gimbal. And then also the gimbal will also sense, since the gimbal is given fed the inputs through the IMU also. So it will help in stabilization. So my my pictures will be uh, what we call very stable pictures, or it will not have a blur or vibration into those pictures. Okay, by using gimbal. So gimbal actually helps you to have a stabilized camera for motion when you are capturing the images or videos. Okay. Then, as we talked about the frame will also be fitted with the landing struts. Okay, there are these are the legs that drone rests on when it is landing or grounded. Comes in a different shapes and sizes as the design of UAV. Okay, so there would be a different shapes and sizes as the design of the UAV is there. And these some drones also can have a mechanism to fold this drone. So some drones, like you see here, inspired drone or drone is there, where the what we call the landing gear goes upside. Okay, go a little bit up, so that it is not affecting the motion of the camera. So your camera can actually move into all 360-degree view. Okay, so it can give a 360-degree view without the landing gear comes or obstructing the view of the camera. Okay. So as we talk about the radio, about the quadcopter, the radio transmitter and receiver, so RC, radio control transmits the inputs given by the pilot to the receiver via 2.4 gigahertz. This is what we have seen in the spectrum, okay, which talks about UHF, right? 2.4 gigahertz. The communication link preferred frequency in this device is 2.4 gigahertz because of the maximum efficiency. Whereas your video transmission preferred frequency is 5.8 gigahertz, as it is provides the noise free and the best quality video signal. So these are the two frequency on which your transmitter and receiver, with respect to the radio, is working, and the video transmission. Like from your FPV camera, the video is being transmitted on 5.8 gigahertz, whereas the signal between the RC and the flight controller is happening between 2.4 gigahertz band. Okay. So these are the two important band. I mean, this is also one of the questions asked during the Viva to the people, like the communication between the drone, either on the communication link or the video transmission, at what frequency they are being communicated. Okay, so a lot of people sometimes they have given like communication link is between 5.8 gigahertz, video transmission happens between 2.4 gigahertz. Ulta, I mean, they have given, some people have given. So they were also. So you should know. See, these are very very small basic things which people should know uh, when they are, actually, as a pilot you should be knowing all basic things. over here. A lot of people, even lot of institute I have seen, they don't talk about these very small points aspects of training. Okay, so they people do not know how. I mean, nobody talks about video transmission happening at a different frequency. Okay, a lot of people say, okay, it's just between 2.4 gigahertz only. So they think that whatever the communication happening between the receiver and transmitter, same frequency, even the video transmission is happening. Okay, so lot of RPTOs are not imparting this kind of small information when they are training the pilots, so that they can know things better. Okay. Then you have a telemetry also. Telemetry is basically on which the communication is happening, where it gives you the inputs of the UAE to the ground controller station, like ground end is connected to the ground controller. To provide crucial telemetry data like altitude, distance, speed, wind, and wind speed, etc. So dynamic updation of the flight plans and any change in the mission. So all this communication is happening from the ground control station to the drone. So you will have again this transmitter, telemetry transmitter would be there. So there will be one unit fitted on the drone, and there is another unit which is fitted on the GCS, your ground control station. So they will communicate on this line, and whatever is required, like your altitude, distance, speed, wind speed, and others will be available on your front panel of this ground control station. Okay. Now, as we seen in the drone rules about the safety features, right? So there is one thing which is like when you are flying a drone, when it is little bit far off, like when it is very close to you, you can understand the heading of the drone, the front side, back side, or the left and right, and all the things. There are some ways, some drones like the GI drones or the thing, they have some color coding and all the things, or they also have a strobe lights, what we call. Okay, so looking at those, we can always identify its orientation or the heading of the drone. But sometimes it becomes difficult. But then some drones are using LEDs or strobe lights or different colored arms. Like front side you can have a white, back side you can have a red, or even some drones are fitted with the reflective material, so that or some color coding, or they have done it, or you can looking at the drone from afar. Sometimes you get disoriented because drone looks similar from a very far distance, like I would say like 50-60 meters. It becomes very difficult to understand the orientation of the drone. So that time the strobe lights or LED lights can also come into the picture and make you understand the front or the front side. Because when you are flying the drone, you should know which is the front side, because that is the time when you give the push forward or pitch forward. Okay, so that way you know the drone which direction it will move, or else it will be very difficult for you. So this is not uh, easy when you see you are flying a drone in a very long location, far location, visual mode. So that time this front indicator is very critical for us. As we talked about the ADSB, okay, this is a beacon which will actually periodically broadcast of its position, but these are not become a mandatory feature. But in BPLS regulations, when they are released by the DGCA, that point in time, this will become a mandatory component of the drones. So as of now, none of the drones are being certified or fitted with this ADSB component, but some OEMs have this facility into their drone, but they are not active. Okay, so they are not really broadcasting their positions via satellite, or they are not broadcasting any navigation related info. So this is basically a very important uh, component when it comes to the airspace safety when we are flying drones beyond visual line of sight, and you are flying multiple drones simultaneously. Okay? This will become a mandatory and a very important component when you are actually making drones fly from one city to another city or within the city itself also. Okay, so if you see, uh, as of now, hardly you can see a drone flying in a city. But when you see the period when you will have multiple drones flying across the city line, then this will become a mandatory component in the drone. Without that, you will not able to fly the drone. Okay? Without it broadcasting its information, you will not able, because then again, if ADSP comes into the picture, you will have a software called as UTM. Okay, so Unmanned Aircraft System Traffic Management. Okay, so that will also be very much required. So that is the reason why this component is not made mandatory. Okay, so this is not mandatory because we are still not equipped with your airspace map or the UTM software. That is why the DPC is actually delaying making this component mandatory into the rules. Okay.
Yes.
Okay, now let's see what are the minor components you have. So as we talked about, the microcontroller is the brain of the flight controller. So when we talk about flight controller, matlab, it is a very big component or a big module into it, and in that module you will have all these different circuitries. Okay, or there is a big board on which all these things are fitted or these have been embedded on it. Okay, so basically, flight controller will take the measurements from all its sensors, tell the motors what to do based on both sensors and user inputs, often connected to the ground station through the radio and connected to the pilot through the control link. So, in total, actually, you are giving signals or inputs to the flight controllers based on the, again, the inputs received from the sensors, and based on the sensors based on the inputs received from the sensor as well as the user inputs, the microcontroller will feed the information or the required information to AC and to the motors, so that accordingly your drone will perform. Whether when you say pitch forward, that action happens is because whatever the signal you fed and whatever the signal it gets and converts, and accordingly the motor will be performing its functions. Okay, there is a small device or small circuitry which is called as altitude and heading reference system. It tells where the aircraft is moving. So this small piece of circuitry, which normally tells the orientation of the drone. Okay, so it will tell you whether it is doing the roll motion, whether it is doing pitch forward or pitch back, or whether it is performing a yaw function and all that. So this small altitude and heading reference system will give inputs to the flight controller, as well as based on the inputs what it receives, your control panel or your remote will also have those inputs displayed, or even your ground station will also have those inputs displayed, and even the logs will capture all these motions. Okay, so if you download the logs from the drone, you will able to get that you what action you have performed or what commands you have given to your drone, what time you have done pitch forward, what time you have done roll motions, or what time you have done the roll yaw activities and kind of things. Okay, so it will capture all the inputs into the logs. Okay, then there are other components like inertial measurement unit. An inertial measurement unit (IMU) is the electronic device that measures and reports a body specific force, angular rate, and magnetic field surrounding the body. Okay, so there are magnetometer is there, then accelerometer is there, gyroscope is there, compass is there. So all these things will be there, which will actually showing us body specific force, angular rate, magnetic field surrounding the body. All that information will be given by IMU. These are important for autonomous flights. It allows GPS receiver to work when GPS signals are unavailable. That means every time your GPS is been fed, it is also capturing the positions and the motions what has been performed by the drone. Okay, and it keeps in its data. Okay, so based on that information, assume your GPS receiver doesn't require satellite signal. That means the drone will not know uh, where it is exactly right now, but based on the IMU information, it can cross back the calculations. It can find how far it was there from the known signal it has come. Okay, so based on IMU data, it can always lock or it can always see at what position it is currently in case there is a GPS failure. So when in case of GPS failure is there, it will try to stabilize the drone at that point in time, but there are safety features built in where if there is a GPS failure or GPS module failure, or in case you are not receiving a GPS signal, it will trigger the self fail-safe mechanism. Okay, so with GPS, the GPS model is responsible for provisioning longitude, latitude, and elevation points. Okay, it helps the drone navigate in VVLOS and captures the detail of specific location on the land. So when GPS is basically used for BVLS conditions, because we are as of now not flying the drone away from our visual line of sight. But in BVLS conditions, we need to know where actually my drone is flying. So my latitude, longitude, and elevation points inputs will come from the GPS module. Okay. So GPS model helps in enabling return to home capability in case of communication or battery cell phase activity. Okay, in case your battery drains all of a sudden, or some connection problem is there, or something happens. Okay, so in that scenario, like for example, you are supposed to fly with the 50% of the battery capacity only, up to 50%, and imagine your battery all of a sudden goes to 50 or 45. So in that scenario, automatically the return to home uh, feature will be triggered, and GPS will help the drone to come back to that position, that is return to home position or return to launch. It is also called as RTH or RTL. Okay. Based on those, whatever you have defined or in the configuration of the drone, it will land your drone either to RTH or RTL location. Okay. So
So
as yeah, you have a question.
no, not question. From this, shall we continue from tomorrow, sir?
I There are only 6 slides left.
6 slides. Acha.
Yeah, yeah.
Yeah, please.
So this is only a module, and then we just have. I mean, we can after this slide also we can end up if you want. Okay. So inner electronics or a drone. Basically, you have a power module. So you can see on the battery side you have a connector which connects to the battery side, but other side you have a connector which connects to your AC or power distribution board, and then you have a circuitry in between from where the power is taken, and then you see there are multiple connectors which are fed or multiple wires which feds uh, the current and the voltage management from the battery. Okay, so this is something intelligent module is built in into the connector itself. So it keeps providing the inputs to the flight controller how much the current and voltage is remaining in the battery. Okay, so that's the part of the connector. So power module is nothing but input connected to the battery, output is connected to the PDB, and it provides 5 to 6 point volt to the flight controller. It is also a voltage regulator which converts the input into the specific amount of power. Okay. Whereas power distribution board, like if you see in a quadcopter, there are 4 ESCs or 4 motors. So you have only one connector coming from the battery, and it is connecting to either PDB. So you might be connecting your PDB somewhere here on the board, and from here there are 4 connectors which are respectively connected to the uh, respective ESCs or the motors. Okay, from this. So this is your power distribution board. So receives power from the battery, distributes the input to the multiple ESCs, and connect the power. Can power the different accessories. Like if you want more other devices, like if you have a strobe lights or a camera or anything needs to be, so you can from this distribution board, you can make connections to those accessories. Could be HD camera or LED lights, or even the on agriculture drone you have a motor pump. Okay, so all that things can be powered through this distribution board. Okay, so since we already have reached 6:30. So I'll stop here as of now.
No,
Tomorrow,
you can continue, sir. Only 5 slides now. We can
uh,
close this session
okay,
today.
okay. If you're okay to continue, another 5 minutes it will take.
Yeah,
So
sir,
what
please.
are the applic? Now we have already completed the rotor rotorcraft operations and aerodynamics. Now we'll just quickly see the applications. Okay. So applications of drone in various sectors. It could be agriculture for crop health monitoring, soil health assessment, and then improved resource utilization. Okay, with respect to the agriculture. Or if you see forest and wildlife, you can have wildlife conservation, managing human-wild conflicts, and forest protection. So, these are the applications, be it agriculture, forest and wildlife, urban development, like city survey, improved urban planning, project monitoring, project quality assessment, all that things you can do through the quadcopter. Even in healthcare, we have seen during epidemic or pandemic, basically delivery of the what we called as medical supplies and all the things that run to the drones, or even the cleanliness and hygiene. Like if in the shortest time we want to deliver the blood samples or even the blood, what we call supplies, can be done through the drones. Again, a lot of places drone are being used for traffic management. We have seen this also used in homeland security, like lot of border places where the Indian armies or other armies also like USA, Israel, all those people have deployed drones for monitoring. Then whenever there is a disaster, it could be a storm, it could be fire, it could be flood, or even in earthquake kind of scenario. Drones are being deployed for real-time surveillance, search and rescue, as well as delivery of essential goods like, in a faster way. So a lot of time we say the communication is being cut or the transportation is being cut because of the earthquake or flooding and all this. So in that scenario, you can always use a drone for delivery of the essential goods. And we have seen use adoption in the mining environment also, where mining, mineral scouting, or management of encroachment, or control monitoring of the mines. Okay, because mines is a very large area. It is more of this like in a kilometers. Okay, and then it becomes very difficult, and they are in remote areas. Okay, so in that scenario, drones are being very efficiently used or very much useful to monitor the entire mine areas, okay, outside the mine as well as inside the mine also. Okay. So you can see the various applications. I mean, these are some of the top or the most used applications of the drones in the various sectors. Okay. So let's see couple of business ideas what are being used. So we can see for the UA industries, aerial photography and videography is very much. I mean, this is the third most usage of the drones. Okay, so first is your infrastructure, so commercial inspections or survey and mapping services. These are the locations where you will have the number one usage of the drone. Second is the agriculture, and third is the aerial photography and videography, where it has been immensely used. Drones. Currently, drones are mostly used, also getting developed from the logistic delivery perspective. So you can see Australia Post or Amazon has already started drone deliveries, be it for medical supplies, organ transportation, or relief ops, or even a basic, pizza delivery also in US. We have seen happening through the drones by using the Amazon or any private drone operators in those
Yes.
areas like California and Las Vegas. Okay. Some more additional ideas could be like residential home inspections, like check the roofs, chimneys, side cracks, or other structures, exterior damage inspections. Even high towers also are being inspected using the drones. Okay. Then, as we had so many drones available, and as we see almost 30,000 drones have been registered on our platform. So you see, there would be a wear tear and operation. I mean, repairs would be required. So people can. I mean, even if you see, there is a huge number of DJI drones are available, but we don't see too many DJI drone repair available in the country. Okay, so this is one of the segment which is also very critical for people to think. And as we have a computer servicing and repair kind of shops available, or mobile repair parts and repair shops are also available. Similarly, in near future, we'll also see lot many drone parts and repair shops coming up into the picture. Then we have seen drone aerobatic shows like last couple of years back. Drones have been adopted for a lot of uh, drone racing or organize their own like a lot of IITs especially has started adopting the drone racing or drone competition. Like as I told you on Saturday, in one of the college they have organized this kind of activity where they have invited different colleges to participate in this kind of events for their students. And then aerial advertisement like fly banner for businesses, or even the aerial drone show also, where you have number of drones flowing, and instead of firecrackers and all that things which causes the pollution, you can use drones for the display purposes and all that things. So there are endless uh, ideas. I can talk about UAV industry. You can see data analytics, then engineering consultancy, then SaaS-based firms, and then there are other also which have been like software. This is like a software company using, or there could be engineering consultancy. Like as your company is thinking of adopting drones for similar kind of consultancy, right? Where you are doing initially in a manual or a physical way. Here you are trying to adopt a drone for doing that same activity, so that you can plan a movement of a drone or capturing the data what you are currently doing in a physical way through the drones. Okay? And then you can have a SaaS-based form software solution for flight planning control, diversified data processing, analytics, and app development. I mean, there are a lot of I've seen couple of companies which have become a SaaS-based firms, and they have developing the software like land surveying earlier, which was happening through a manual uh, mode. There are softwares which have been developed where you can fly a drone, and you can have a complete survey done through the drone. Then again, I talked about UA insurance covers the liability, damages, and claims to the third party. Even depending upon what cover you are trying to cover, whether it is only covering the drone or whether you are covering the complete uh, cover liability, damage as well as claim to the third party. It could be a person or a property also. Okay, so depending upon that, you can take up the insurance. So insurance industry also has started adopting or started giving the drone insurance to the people. So more and more drones comes into the picture. Yeah, imagine how much insurance industry will also gain from this. Okay. The last slide. This is how we envision our society would be there in the future. We what we call as Internet of the would be adopting drones into our agriculture, have a drone port where the drones will be serviced at both batteries, or it will be a landing or stop gate kind of location, or vertiports what you would call. And we'll have monitoring for smart grids, medical supply, railway monitoring, traffic surveillance, and real-time notification, connecting connected homes also. The factory ecologists within the factory or large factory want to supply from one place to another place. You have seen even drones have been used into the supply chain environment also, whether it's for monitoring or movement of small parcels from one location within the logistic environment, or even also like on duty drones for the first responders. We have seen this medical, somebody is having a heart attack and call up. Rather, it will take some time for ambulance to arrive, or it will take some time to doctor to arrive on a place. There is a very good video where a person has faced with the cardiac heart attack, and the drone comes. That lady calls, and the drone comes with the diffuser, what is called that diffuser, and she gives that treatment based on the the instruction from the doctor who is sitting remotely. So the drone camera actually is viewing the footage to the doctor remotely, and it is giving instruction to the lady, and according to the lady takes uh, performs the activity, and that person is saved. Okay, so that's how the first responder what we call. Then again, private and hobby use, climate monitoring, driverless buses or driverless trucks, where we need monitoring of these things. So, based on that, drones will be very much useful in this kind of manner. I mean, these are some only use cases what we can see. I mean, we can put so many things into the one picture, make that how drones would get adopted in our future society or future life. This is what is this picture depicting here in the image. Okay. So with that, we are completed with the topic of rotorcraft operations and dynamics, aerodynamics. Okay, so from today's topic, only what we are left is the small this thing. I think so, which we will start tomorrow morning. And it's just 10, 12 slides, I guess. Okay, so hybrid drones, which is remaining, and we will see tomorrow morning. So yeah, we'll be able to start tomorrow morning by 9,
Yes, sir, we can.
right? So
Yeah.
try to be there on time so that we start on time and do the. I mean, only small topic is remaining from the today, so we can cover up tomorrow. And then tomorrow topics are not so lengthy. As well as in today's topic, I have taken little bit more time into the drone rules because that is the most important topic with respect to the flying. Okay, so in another some time you should be able to receive the mail from me, which will have the summary sheet as well as the drone rules 2021 document. Okay. So try to see if you can get the printout of them, get the link. I mean, not only printout, but you try to read. Spend some time. Not necessarily the complete document need to be read at a stretch, but whatever topics we have done today, you can go through them into the summary sheet and try to summarize the things what has been taught in today's session.